So I was trying to catch an ether bunny this weekend. You know how I caught it? I had to use an Ethernet. Just a silly little networking joke that I found on the internet. But what do we got going on today? We have an OSPF trouble ticket. All right, so what's the problem here? R5 cannot ping the loopback address of 1.1.1.1 on R1. Oh no! So who did they call? They called CCNP Seth, and I'm here to fix it. So I come in and I look at this topology. They're like, all right, CCNP Seth, here's what we have. For some reason, R5 cannot ping R1. So here it is. So I look at it and I'm like, all right, we got area 0, we got area 1, we got area 2. So what I know about OSPF is that all areas need to be adjacent to area 0. So area 2 actually doesn't have one. And if we look at some of the routers on area 2, they probably don't have a route to area 0. So let's actually bring up area 4 real quick. Oh, look at that. What is that? An OSPF adjacency error. Exchange start down. Maybe that could be an issue for what's going on in our topology. But let's actually see if it has a route to 1.1.1.1. So let's hit enter. And it doesn't. Doesn't even have any inter-area routes. It doesn't even have routes from area 1 nor area 0. We should see that with IAs. So, okay, there's an issue there. Let's see if R3 has routes to R1. Let's bring up R3. What do we got here? Neighbor down dead timer. All right, so we just have problems all over the place. So let's do show IP route. Even router 3, who is in area 1, doesn't have a route to 1.1.1.1. Wow, so we have a big issue here. So let's look at the routing configs to see if router 3 is actually sending hello packets and getting neighbor relationships. Clearly we have neighbor relationships to 4.4.4.4, which is this guy. So actually let's do show IP OSPF neighbor. We only have one neighbor. We should be expecting 2 neighbors here. That's an issue. So let's do show run section router OSPF to see what's in the running config. So, alright, looks like there's probably a loopback address, some actual interface right here. Notice it's pointing to area 1, so it should be this guy right here. And then we got area 2. So, okay. What does router 2 have? So let's pull up router 2. And we got another issue here. Went from full to down. Neighbor is down. Dead timer expired. Wow, what is going on here? So let's do show run. Let's do section router OSPF. Oh. Show run. Alright. Oh wow, look at that. Area 1 has some sort of authentication going on. It says message digest. That is something that router 3 did not have. So maybe we should put that in there. So let's go ahead and do that. Config T, router OSPF 1, area 1. What was it? Authentication and message digest. Cool. Does that bring the neighbor relationship up? No, it didn't. So, yeah, we have authentication, but what is the actual authentication key? So it should be sent out with those hello packets. So let's look at interface F01 to see if there's some sort of authentication key set on router 2. So let's do show run interface F01. Aha, look at that. IP OSPF message digest key 1 MD5 CCMP Seth. So let's actually copy that. Copy that to the clipboard. And let's go to router 3 and apply that on the interface of F01. So interface F01. Let's paste that in there. Bam. Do we get a neighbor relationship? Hopefully, actually. Sweet. So because of that, do we have a route to 101.1.1? No, we still don't even have any IA routes. Well, let's take a look up at our topology again. Area 2 is supposed to have an adjacency with Area 0. Router 3 has no adjacency with Area 0. So what do we have to do here? Well, if you remember in your CCMP days, if an area doesn't have an adjacency to Area 0, but there is a transit area, we can create a virtual link to each other. So let's go ahead and do that. Let's go into router 2. Let's see if there was an actual virtual link configured for it. No. So we actually have to do it on both sides. So router OSPF1. And let's do area 1 virtual link. And what is it? What is the router ID of our neighbor? So 3.3.3.3. Type that, and we got to do the same thing on router 3. Config T, router OSPF1, area 1, virtual link 2.2.2.2, and let's get a neighbor relationship. Cross our fingers. Oh, come on, don't make me look bad. Oh, sweet. Yeah, that's what we're looking for. So let's do a show IP route, and let's see if router 3 can finally ping 1.1.1.1. We got a little bit more routes, but we didn't get inter-area routes. Let's wait for the databases to actually sync. All right, we're getting a little more. Oh, look at that. We actually got a 1.1.1 route. Notice that it is not an OIA route because we finally got that adjacency for area 0. So actually, let's ping that 1.1.1.1. Sweet. All right, so that means router 3 should actually pass that traffic to router 4. So let's go to router 4. Show IP route. Does it have a route to 1.1.1.1? Sweet. So let's ping that. That worked. So router 5 should have it, right? So let's go to router 5, wherever that is. Look at all these messages. Why is it going from down to down and then exchange start to down? Ugh, it's annoying. Show IP route. I don't even have a neighbor adjacency, or I don't even have any OSPF routes. So let's see if we have a neighbor relationship. Show IP OSPF neighbor. We do. 4.4.4.4. That's router 4. But we have it's in the exchange start state. Let's see what neighbor 4 says. Router 4. Show IP OSPF neighbor. He's still stuck in the exchange start for router 5. Why is that? What could be the issue? Let's go into router 5. Do show IP OSPF interface brief. Yeah, everything, the hello packets are working. So what else could be the problem here? We have a neighbor relationship, but we're stuck in exchange start. And we're stuck, what? On both sides, exchange start. And let's go into router 4. We're still stuck in exchange start. So what else could be the issue? Let's look at show IP interface F01. Oof, what happened there? All right, line protocol is up. There's our address. Look at our MTUs. 1492. Normally Ethernet segments are 1500, but does that make a difference? Maybe. So let's keep that in mind. 1492 for the maximum transmission unit for this interface right here, F01. So let's go to router 5 and let's do show, what is it? Show IP, interface F01. Let's expand this. Line protocol is up and up. There's our address. MTUs is 1500 bytes. That's normal, that's default, but router 4 actually had a different value of 1492. Does the MTUs matter for OSPF to have a neighbor relationship? Clearly it didn't matter for a neighbor relationship because we got one, but does that affect the actual OSPF process? Let's do a show run interface F01. Someone manually set that. How about we change that? Let's change that for it to match. Config T interface F01 IPU or IP MTU, what, 1500? Exit. Oh, wow. We got an OSPF change. Look at that, loading to full. Wow, that's good news. Let's get into R5 and tab. Let's see if it could finally ping it. Show IP route. I'm so excited I can't even type fast, or I can't even type correctly. Oh, look at that. We got a route. So let's ping it. Sweet. We actually pinged that one route, that 1.1.1 route from R5, and that's actually our objective. R5 cannot ping the loopback, so we did it. So what did we actually do here? Well, we needed to create a virtual link between area 2 and area 0. And area 1 was our transit router, so we needed to create a virtual link between these two routers. Also, we found out that there was some authentication. I'll just put ATH. So there was some authentication between area 1. So router 3 and router 2 could actually form an adjacency. So after we connected that together, R3 was able to ping R1, R4 was actually able to ping R1, but there was an actual mismatch between R4 and R5. R5 had a neighbor adjacency with R4, but it wasn't getting any routes. The problem was because they were stuck in exchange start state, and because the MTUs were mismatched, so I'll write that out, MTU, the database descriptor packets, they were not in the same format, and that was due to the MTU. MTUs need to match. Let me write that a little better. They need to match because in the database descriptors, they need to match the same packet size. So that was the issue for this trouble ticket. So there were 3 issues. Area 1 authentication, a virtual link, and then an MTU mismatch for R4 and R5. So, that was a doozy. But that was good, though. This was a good trouble ticket. We applied multiple OSPF theories to this topology, and since they brought us in and we know how OSPF works, we were able to fix this problem. So I hope this was all informative for you, and I'd like to thank you for viewing.